Hi and welcome to this week's video. In this one we're going to try and deal with the tail plane, the elevator control horn and the control tubes going from the control column back. We'll see how far we get, so let's get cracking. Well, my plan was to put the elevator horn into position on the elevator. There's one slight wackiness about this lot. On the plan it doesn't give a dimension out from the center line to where it should be, so I ended up sighting sort of down, looking at the rear spar carry through where the reversing idler levers are mounted, to see how far out from the center I could be. About 2.5 inches, and so I've put a mark on there, 2.5 inches. So that's where the horn section would be. Now let's have a look at this horn section. Here it just tells you that it's AT19. This is AT19, the part number. It doesn't give any dimensions on here as to what it should be, the sizes of it, but this came in the packet. On here it says that AT19 is made out of 1/8 by 1.25 inches by 5.5 inches. So I'm assuming the 5.5 inches is from the top to the very bottom. And my one is, as you can sort of see, about 4 3/4 inches. Here it's got a whole series of holes. On there it shows a whole series of holes. On here we have 2 holes, so yeah, exactly where do you put it to get the right feel, I don't know. And yet everywhere it's sort of showing it being attached to the very end. Okay, very end hole, so what's the point of having the other holes? It's not like I'm going to try and change the range of movement or the load, so I'd rather just have the one hole. So what I've done is I've asked the good folks online who've got youngsters, what is the distance from there to there on their aircraft, because obviously that works. And then I'm going to make up a new one of these. Second reason why I want to make up a new one, well, a couple of reasons why I want to make up a new one. Right, I want to have the rod attachment in line with the hinge. If it's not, then you end up with like a differential movement. So as you move the control column backwards and forwards, for a given amount of control column angle movement, you get a amount of elevator movement. With the mount being set back here, you're going to get a faster range or greater range of movement in up elevator than down elevator for a given amount of stick movement. You might go, well, that's logical, we want to have a greater range, but it also makes the stick heavier in that format and lighter in the push, and I don't like having the stick lighter in push, so I just want to move it forward. That way it'll be equal both ways. It won't make a huge amount of difference, but as I'll need to remanufacture this anyway, might as well get it sorted. Why do I need to remanufacture it? Well, it doesn't comply with the plan from what I can see, but that's a minor issue. This lovely little angle bracket, which is what it should attach to, the holes, well, I don't know if you can see, one hole lines up. You can make a choice of which one it is. I do wish it hadn't been drilled to final size, but the other problem with that is that little plate there is 1.25 inches long, and in accordance with the drawing bit, it should be 1.5 inches. You go 1/4 inch isn't a lot, but that 1/4 inch means that we've got quite a high load going through the wood, you know, when you're trying to put the twisting force in. You need to have this as far apart as really as you can afford to have it. So that's another slight issue. And also this piece here, these holes want to be in as close to the angle as would allow the head of the bolt and that to be able to be done up. So quite a chunk across, because the further out it is, the more we've got of that sort of type motion. We don't want that. So I want to make up another one of these. I'm making up another one of those. I might as well get that bit sorted out so everything's good. And this plate here, which is to spread the load, it's no good the way it's been designed or made up, because it sticks out over the front edge there. So when it's on the top of the tail plane, as you go up elevator, it would interfere with the back of the spar of the horizontal stabilizer. So that needs to be sort of back. So those holes are in the wrong place. So that's not usable. Sorry, Fisher, if it sounds like I'm sort of having a go at the fabrication, but this part that's been made here, out of all the bits which I've had from in the kit, is a complete disaster area on fabrication. That would work. That bit doesn't work. That bit doesn't work. I would say don't finish drill. Just have it one size down. We should be all capable of finish drilling. Make sure the parts actually match, correct length, or just give us some material so we can fabricate it ourselves. It's not particularly hard, although there is no drawing, at least I couldn't find one specifically for this component. Ranted. So I'm stuck on the tail. I can't do any work on the actual tail plane bit for now. I'm just going to put that to one side, and I'm going to start working on the controls going forward, and we'll see what we can get built and done. I just bored a hole through just to let it come up through here, because I don't know how much it needs to move backwards and forwards until I've got the tail plane on the other end, and then I may well use this as the limit stop for forward and back motion, and then try and work out what we're going to do for the aileron. I think I'll use a stop system that will go onto here, but this may well be the simplest method for doing the elevator pitch limit. I've gone back to here. I've got the walking lever or reversing lever, depending on what side of the pond you come from, in position, and you can sort of see this is all sticking out of the bottom of the inner skin. So yeah, but this isn't outside the aircraft. A lot of people might think. There is some sections like that, and then coming off these are stringers. So there's a pair of stringers which will go past here. So the tube should, in theory, go across somewhere underneath that. I'm not 100% convinced at this end here, but we'll find out. Might need to lift this up very slightly, I don't know. And then the stringers will go from the very front here all the way across down to just shy of the tail wheel mounting point at the back there, to put a little bit of shape into the bottom, and that hides this lot. So here somewhere I'll want to have an access point for annual inspection, and somewhere about here I'll want an access point for annual inspection, so I can actually look at what's going on here, and also for my trim system, which you've yet to see coming together. That's something else. So the first bit I'm going to do is going to make up spacers to put in rose joints at each end, and inserts to go into the tube that's going to go from there to there, because I'm doing it differently to the way it is on the plan. I don't like the idea of having two U bracket sections held together with a bolt longitudinally, which would be hard to inspect, a plain bolt going through here which could pinch and make it tight, a plain bolt going through there which could pinch and make it tight. At both ends of this rod, that's just asking for a lot of wear and tear there. So and the same here. So both ends of that, I don't like the idea of that. So as I've modified and put bushings into various other areas, I'm going to use the rose joints. So step one is carried out. I've faced that. I've got to just take that nipple off the end there. This is turned down. It's about 37 millimeters long along there, turned down to approximately 16 millimeters. So stage two, board out, ready to go there. So I'm now going to do the same to 3 more like this to get them exactly the same stage, and I'm going to change the chuck over to 4-jaw chuck, center this little lot up and turn the other end and drill in so I can tap for the IN. So the next section was to face off the piece and to drill through 5.5 millimeters tapping size for quarter UNF. So that's what we end up with, a bit like that. This has now got to be turned down in diameter to match the tube, and a little chamfer just put on the edge just to neaten things up, and then they'll be ready to fit. So there it is with the chamfer machined on, turned down to size. All that's left now is to run the tap through there by hand. I'm just going to clean out the inside of the tube here. I'm using a 12 bore cleaning brush, 12 gauge to our American brethren. Just going through like that. You sort of saw that's cleaned out a lot of stuff. So I've set the clino here to 0 using the verticals on the fuselage size as a datum, and I've got the long elevator control tube there clamped so that it can't move. I'm just going to temporarily fit this end in here. I'll screw this in, and then without using the spacers, I don't need to really use the spacers at this moment in time, I'm going to set it so the control column is at 0 as well, he says, hopefully. Like that. You can now put the gauge in, and that's it, 0 there. Right, Houston, we have a problem with the pivot going through with a shorter length at the bottom, which is how it appears to be on the plan. This bracket this way up, as it should be according to plan. This bit should be flush with the top of the spar carry through. Let me show you. Spar carry through, top of spar carry through, flush on that drawing and flush on that drawing. So that's the way up the bracketry goes, flush with the top. Well, actually I've inset it very slightly, so that should actually give us more clearance, but no, that touches. So I thought, okay, what happens if I've got these levers the wrong way up, because it doesn't show which way up the levers go. So if I go to those the other way up, and we end up with something akin to that up there, like that. Now we've got a big slope and lots of gap there. That's not quite right. So my next thing I'm going to check is I'm going to actually try and see what happens if I turn this little bracket the other way up and see if that gives me clearance. Bearing in mind these bits of metal are as per the drawing, and okay, with the bracket the wrong way up in accordance with the plan, I now have that control tube nice and parallel. Bearing in mind that this is the same height, or same distance away from the pivot there as on the plan. That lower tube there is in the same position as it is on the plan. This is flush with the top of the rear spar carry through as per the plan. These dimensions here are all correct. I have to have that upside down to get that parallel. See that? We'd have to bend the tube. I don't want to bend the tube on the grounds that you know, when you want to adjust it, you want to adjust things a little bit at a time. So I'm now going to have to just reset all that lot to make sure that's the right length, and then I can set up and wire lock that end. Okay, I'm going to show you how I'm wire locking these eye ends. The eye end here is got thread lock on it going into the ferrule at the end, but it's got this lock nut fitted here to stop it from having any vibration and to lock it in sort of position there. In theory, even wire locking it, this would be able to turn, but bearing in mind that as this one tightens, the other one will be loosening, or vice versa, so it's not going to make any changes to the length of the rod. Now some rose joint eye ends have got a hole drilled in here, in which case you do different wire locking system, you do a figure of 8. But for me, these aren't, and I'm not going to drill them. They're so small, there isn't enough material there, and it would reduce their strength. So what I'm using here is just aviation wire locking wire, 21 gauge SWG, whatever way you want to call things, standard wire gauge. This is a standard wire locking or safety wire grade used in aviation, as our American brethren would call it. Right, now the rivets I used to hold these ferrules in are monometal, but they're brake head. There's two different types of blind pulled rivet in the sort of tucker pop format. There's brake head and brake stem. The brake stem ones, the little end of the mandrel that forms the rivet stays inside the rivet, doesn't come out. You'd have to, you know, punch out, and sometimes that's when you have to drill out these rivets. With the brake stem type, you have to punch out the core. But with these being brake head, the head comes off, and I rattled it out through the hole where the screw thread is. It allows me to put, he says, the wire right through the rivets. I don't need to have a tag put on there. So I'm just putting that through, bending that through 90 degrees and wrapping that around. I've got wire locking pliers, so I'm going to use them. Just put a few twists in and cinch it up fairly close to the rivet itself. And now I'm going to go round. I want at least 45 degrees, so I'm going to be going round to that hole on the other side there. So there we go. Don't want to have too many twists. Sufficient twists there. Make sure that that's good. Put the end through the nut and pull it tight. Make sure everything is tight. Just give that little tweak. Bring that one around. Now with my wire locking pliers, I'm going to rotate it in the opposite direction to the bit that we did with the tool, and I'm going to make sure that's tight. Nice angle, sort of 45 degrees tight. It's not going to come loose anywhere. Trim off that piece. I turn the pigtail over. Making sure that stays nice, and I just twist that at last. A little bit of a half turn there, so that it's secured in the bottom. So there we go. That's the wire locking, nice and tight. Done both ends. Shouldn't shake around. Keeps everything nice as it should be, and we're secure. There we go. Thank you for watching. If you enjoyed the video, please hit the thumbs up. You can subscribe or even hit the little bell notification for future videos. Any comments would be appreciated, and I'll try to get back to you as soon as I can. Remember, go fly and feel the sky.